Hello and welcome. We're going to be going over the distributive property today. So in our inquiry, it says what is the product of A and A plus B. We're going to be solving that today by seeing how distribution works. So what we see is when we have something along the lines of 3 times the quantity of 4 plus 2. The distributive property allows that 3 to be broken down and go to the 4 and the 2. So if we use some colors to show this off. So we see the 4 plus 2, we remove the parentheses, and the 3 got attached to both of them. So our key concept for the distributive property, for any A, B, and C, A times quantity B plus C is equal to AB plus AC. This is distributive property. Same thing, if you do it in reverse, so quantity B plus C times A gives us BA plus CA. Same thing happens for subtraction. We have two examples here. 4 and 9 make 12. So we know, 9 and 3 make 12, and 4 times 12 is 36. Not 36. That's weird. Why did they do oh, I see, because we're doing two separate sides to prove it. Okay. Yeah, over here we get the 12. Over here we know they're equivalent, so by breaking them down, these are equivalent statements and proves they are the same. The symmetric property of equality allows the distributive property to also be written in the reverse order. So AB plus AC is equal to A times quantity of B plus C. Over here, if A times quantity B plus C is equal to AB plus AC, then what does AB plus AC equal? Well, they give us AB plus AC. We see that they both have an A. We pull the A out front and just are left with B plus C. Example 1, assume that high school students spend an average of $180 on back-to-school shopping during the months of June to September. Write an expression to represent the amount of money spent in August if the amount of money spent in August is equal to the amount of money spent in July minus the amount of money spent in June. Evaluate your expression using the distributive property. All right, so let's take a look. Write an expression that represents the amount of money in August. Okay, so August, so money in August is equal to the amount of money spent in July minus the amount of money spent in June. All right, so August equals July minus June. Describe the task in your own words. Then list any questions that you have and how can you find the answers. Well, how much we spent in August is the expenses of July minus June's expenses. And questions we want to know, well, how much did we make in July and June? Or how much did we spend? How will you approach the task? What have you learned that can help you complete this task? Well, we've already set this up right here. we're going to say construct an equation. An equation has two sides equal. We do. What have you learned that can help you use this? This would be section 1.1 and 1.2. And that's math sentences. Allows us to translate written words into math expressions. What is your solution? So, again, so we'll just say this is $AUG equals $July minus $June. And it says, what is the total amount spent in August? That's interesting. Let's see. When are you likely to spend? All right. It says, assume that a high school student spends an average of 180 on back-to-school shopping from June to September. So this is going to say if we average those three, it's 180. So we can then add in August plus July Oh, I guess that'll tell us what the total is. So if we add these three together, AUG plus July plus June equals 180. Anything we can do from that? Let's see. Well, we can put August all by itself, and we can move July and June to the far side, which will give us 180 minus July and minus June. We know that August is equal to July minus June. So if we do that, so we have two statements. Let's go. So AUG equals 180 minus July minus June. Swap what August is equal to. I have a negative June on both sides, so we can cancel that. Oh, this isn't going to be fun. So July equals 180 minus July, move it over. We then get 2 July equals 180. So then this becomes July equals 90. Now that we have July, we could go back and plug this in. 90 minus 90, so if we plug this in here, oh, we're just going to keep solving this then. So if we have our assumption that July equals 90, let's take a look, plug that back in. So let's use our equation right here where we had July. No, that won't work. Well, we have July minus 90. We know the total is 180. If we put 90 right there, that helps us solve a little bit. Oh, I know. Let's go. If we plug in August, no, that cancels out the Junes. So let's see, we know it's going to be less than 90. Oh, are they trying to have us do a percent and decimal? What are the likelihood that you're going to be doing your shopping? This question's weird. So by plugging in the numbers we have, I think they might be telling us that we have to go, that these percentages go to this number, and it's broken down. When are you likely to do the majority of back to school shop? This is a terribly constructed question. If we use these two in conjunction, I think it wants us to convert these into percents and then use that to figure it out, but it doesn't explicitly say that. It just says likely, so this is a probability of spending, not actual spending. Yeah, bad story problem. Let's move on. Bertel's swim team practices 5 days a week. Each day they spend 15 minutes stretching, 45 minutes swimming laps, and 30 minutes lifting weights. Which expression represents the number of minutes Vertil's team spends in practice each week? Select all that apply. Well, they practice 5 days a week, so that means every one of these activities is going to be done 5 times. So we know total minutes will be 15 plus 45 plus 30. Hey, we got that right here. And if we add them together and multiply by 5, that one will do it. All right. Then if we take each individual one, multiply it by 5, like C, that works too. Let's see. Nope. 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 A and C. B. How much time does Vertil's team practice each week? Okay. 15 and 45 make 60. 60 and 30 make 90. That's an hour and a half. So it's an hour and a half a day, 5 days a week. Well, an hour and a half and 4 is 6 hours, so 7.5 hours. And you can do that by doing 90 minutes times 5, and then we do our conversion of 60 minutes to 1 hour. Oh, 450 minutes. Oh, you didn't convert it to hours. Interesting. Example 2, mental math. Use the distributive property to rewrite and evaluate. All right, so I get what they're saying here with this one. Instead of making this 99, we're saying this is the quantity of 100 minus 1.